Alright, let's jump back in. Number 7. How many grams of magnesium sulfate are needed to prepare 250 milliliters of 0.425 molar solution? So we're looking for mass of magnesium sulfate. We're going to prepare this volume of that molarity. So if you remember that molarity is moles per liter, remember that's a conversion factor between volume and quantity. So we've got volume to start with. We're going to use that single unit number, that 250.0 milliliters. We're going to take that to liters first. Why? Because molarity is moles per liter. So we got to have this in liters in order for that to cancel out. So 1,000 milliliters per liter. Next, we're going to use that molarity, and we're going to go from moles, and in this it is mag sulfate, which is MgSO4. If you got your nomenclature down, then you know what I'm talking about there. If not, woo mercy, you need to go practice that right now. Alright, so again, this is using the molarity that it says is 0.425 molar. Then that means it's 0.425 moles for every 1 liter of solution. If we were to stop there, let's see, milliliters would cancel, liters would cancel. We would be left with moles of magnesium sulfate. We're asked for grams, so we got to go one more step. That one more step is going to be going from moles of MgSO4 to grams of MgSO4. That information comes from, good job, periodic table. When we go look it up, that is 120.38. Okay. So in that last step, moles of mag sulfate would cancel, and you'll be left with grams of magnesium sulfate. Yes, that was a 1 there. And so when you plug and chug, you're going to get 12.8 grams of MgSO4. Alright. Let's look at the next one. It says if 50 mils of 6.50 molar H2SO4 is diluted to give, that's screaming, this is a dilution problem, you're going to use the dilution equation. So you're going to dilute that to give 1.3 molar solution, and it wants to know when you add enough water to make it 1.3 molar, what's the final volume going to be? So recognizing that these go together as the concentrated, and that this guy is going to go with whatever you're solving for, the final volume. So M1V1 equals M2V2. So this is V1, that is M1. This is M2, and it is V sub 2 we are solving for. Solving for this guy. Now, you can do this one of two ways. You can plug it in the way it is, which is the way we have been doing. Some people really like to solve the equation first, so I'll show you. If you just do this, bring m sub 2 over, it will be in the denominator. If it's multiplied on the right, it's divided on the left to give you v sub 2. Doing it this way, you just have to be a little careful, make sure that you're assigning things right. Alright, so M1 was the 6.50 molar. V sub 1 was 50.0 milliliters. And then M sub 2, which is now the denominator, is going to be 1.30 molar. Following your units, the molarities will cancel, leaving you with milliliters. So V sub 2. When you plug and chug through that, you're going to end up with 250. But be careful, because you're going to need 3 sig figs because of the 50 and the 6.50. So you need that 0 to be significant, which means you have to put a decimal place behind it. And the unit is milliliters. Now, be careful if you're doing a multiple choice test. For this one, it said, what is the final volume of the dilute acid? And it did not specify units. In that situation, the safe assumption would be that it's milliliters. If you're doing a multiple choice test, sometimes there's going to be an answer in milliliters and an answer in liters, and you better read that question and see if it was specific about which one you're supposed to be solving for. Since this one was not specific, I'm going to assume they want the same volume unit as the volume they gave me, and I'll stop at milliliters. Okay, number 9. Sodium acetate has a formula weight of 82.034 grams per mole. What is the molar concentration of a solution prepared by dissolving 4.10 grams of sodium acetate in enough water to prepare 2.50 times 10 to the second milliliters of the solution? So you know exactly how much of the stuff, what the stuff is, and you know that you're supposed to prepare this volume of solution, and it simply says what's the concentration gonna be. So get rid of all the extraneous words. How many grams you have, what the total volume is gonna be. So it's giving you exact numbers you need. So you're gonna say 4.10 grams of NaC2H3O2, and that will be dissolved in 2.50 times 10 to the second milliliters. So you need to get to molar concentration. So you need moles on the top, liters on the bottom. So you got 2 steps to do. You need to go from grams of NaC2H3O2 to mole. NaC2H3O2. When you run to the periodic table and you add all that up, you're going to get what it gave you in the problem, 82.034. Alright, doing that step is going to get you from grams of sodium acetate to moles of sodium acetate on the top, which is what you need for half of your job. Now keep going. You need to get from milliliters on the bottom to liters on the bottom using the 1000 metric unit conversion. Milliliters will cancel and leave you liters on the bottom. So now you're ready to plug and chug through that. When you do so, you will have moles of NaC2H3O2 on the top and 1 liter of solution on the bottom. Will be 0.200, 3 sig figs. Because of the 4.10 you were given and the 2.50 you were given, both being 3 sig figs. You can rewrite that as 0.200 molar in NaC2H3O2. And that would also be correct. Alright, number 10. Okay, we have, what is the molar concentration of a solution prepared by dissolving 0.100 moles of potassium nitrate in enough water to prepare 400 mils of solution. So you have the quantity, you have how much, and you have the total volume solution. So set it up as a concentration, 0.100 moles. And it's potassium nitrate. Total volume will be 400 with a decimal point so that you have 3 sig figs milliliters of solution. and that is moles per milliliter. So your only job here is to get from milliliters to liters on the bottom. Once you do that math, moles will remain on the top, milliliters will cancel, and you will be left with liters on the bottom. So you have gotten to moles of KNO3 per 1 liter of solution, which is molarity, which is what they ask you for. So if you plug and chug through that, 0.250 moles of KNO3 per liter, 0.250 capital M KNO3. Alright, if you can do the problems that we've done in the last 2 or 3 videos confidently and you understand them, you are ready for this part of the test. No problem.